Taking a very small example of a very small seven-storied building which we are trying to experiment in, how we can improvise, innovate, and try and get rid of all the problems that have been discussed here today. Normally, we have never thought of steel for housing projects before. We were into industrial projects, and some mostly steel came into where we thought the spans are going to be big, and these are some of the structures that we've been doing over the years. Typical factory buildings, some different configurations. This is a typical small bridge we did at Calcutta. Some typical cantilever trusses for stadiums, etc., etc. And when we started designing these, thinking about affordable housing, first thing was the cost. We talked to the developer who is trying to get us into all this, and we said that whatever happens, we have to remember that it's not going to be cost effective. It is going to be at least 10% plus. But there are lots of issues. Today cost is not the governing criteria. But generally, if you can really start from looking at space, constraints, and we told him that we would not like to design something which an architect has given us, but we would like to sit with the architect and look at how we use basically all the properties of steel into designing that building. It's not going to be, there is not something spectacular that we can do in design, but generally if we can use all its properties, all its proper lengths, and minimize work on steel, etc., etc. Then, so we started off in preparing a layout. How would we go out preparing a layout? What would be a typical column grid? What would be a suitable size? And all the rest of the things that we see, the structure could be energy efficient with respect to openings, material, build forms. We'll not be talking about energy efficiency, etc., etc. But generally just a small example of what we tried to do and how we went about trying to, come somewhere near where we could build really fast and it would be simple, and we could say that yes, we can build lots of such units, and we could call it, so to say, mass housing. We started with a simple plan, you can say a one-room unit, where this is the way I was trying to plan it to them, because normally when we are building in structural steel, it is basically elemental, it is segmental, you could say, where it comes in bits and pieces, and it's not like monolithic like RCC. So the biggest problems we have are with our toilets and our terraces, which have to be waterproof or sunk and things like that. So in my plan, I tried to push the toilets and my terraces outside my main grid. So this is just a small element that we did. This is a, you can say, one-bedroom apartment where I have a living room, a kitchen in between, and a bedroom, and a toilet pushed outside. Similarly, this is just a small plan of the same. I'm sorry, you may not be able to see the dimensions here, but tentatively this is what I did, and then what we did was we just try and mirrored the plans here and there so that we could get more and more units. We had attached a passage to one side of that plan so that we had a mirror on one side. The same side we mirrored the other side so that we could get more units. Similarly, we had a two-bedroom units. For this also we did the same, where we had two bedrooms at the extreme sides, and you can say the kitchen in between, the living room to one side. What we tried to do here was that we at least tried to focus on two blank walls everywhere, on the longitudinal side or the lateral side, so that we could, instead of getting into all the nitty-gritties about lateral loads, we could have at least one brace frame, so to say, every 3 or 4 between bays. So this also we flipped here and there. You can see that we have mirrored it to the left, mirrored it to the right, and then we get those additional columns. We have that passage in between. We managed to put in a staircase and some lift shafts, etc., etc., so that the main integrity remains the same. And if you see here, maybe, I don't have, but the central wall you see remains a dead wall, irrespective of whatever happens. We have the edge, which are dead walls, and the central core also, which is a dead wall. Then again we flip this over, and with numerous combinations here and there, you saw that we started from a single unit, and now we come down to nearly, if we take the whole layout, we have fit in 18 units, which are mirrors of all the plans that we saw in the beginning. And they are so adjusted that all the columns and all the beams that we plan to be can be on a single grid. What we did with these plans was we did not try to fit the columns at all the wall junctions or things like that, but we just took an optimum size. First we took 3 meters, then we took 6 meters, and along the length of the building we have managed to put columns at 6 meters and 3 meters center to center, so that my beam lengths become optimum. And then that becomes one grid. We have a central passage. Again, the columns on both sides are interconnected. And the other side also, we are using the same things. As I said, at every end and after every 3 to 4 units, I have 2 blank walls, which give me my bracings in both the directions, the lateral direction and longitudinal direction. And that saves a lot of things. We just try to do analysis just to compare what is going to be the difference in cost, and we also did a small RCC frame structure analysis for this. The costing that I'm going to show you is not going to be exhaustive because there are lots of other options, but this is just to show that it is comparable to what we are trying to do, and it's quite easy. We have worked out some of the quantities with the 2 options, structural steel and the conventional RCC. Of course, there are so many other things that we could attach to this, like the walls, like the floorings, etc., etc. But I mean, that can be evaluated later on. We are just trying to see whether we can build a simple steel frame with all the necessary details in analysis and still try and make it feasible and simple, and so simple that it can be executed inside. Normally, all the presentations we see that, yes, we need lots of detailing, we need good contractors. As we say, the plan becomes so simple. You can see the columns are there, my columns are there on 2 sides, my toilets are outside, so that can be stuck on or they can be done along with whatever we are doing. This is just a simple RCC analysis that we do normally. And then we come to the steel part. Here also, what we try to do with the steel is we are experimenting with various floorings. If I'm doing decking sheets, then this is going to be my grid. We also experimented with precast slabs, which are now quite easily available in Pune also. So then our central beams get off and only my main beams remain the framing beams. So there also, that also we are also working out the cost. But again, this really simplifies. You can see that most of my internal beams are the same size. Most of my external beams are also the same size. So we can really economize on the selection of the members. My columns also, depending on every second floor or third floor, can remain the same. So, I mean, there is not much that we can make mistakes on. And fundamentally, it remains a very simple and a very executable plan. So most of the complications that we would normally have or associate with building with steel, things get abandoned here. So we have minimum type of connections, minimum member-to-member connections also. And this follows, the whole grid follows the same issue. I mean, we have tried to fit the framing into the plan. Generally, you can see this section will also show you that all the ends and the centers also are braced in both the directions. As I said, we have planned it such that the wall of the bedroom and the passage is a dead wall. So I can have my bracings there, and also my sides, my bedroom sides, and after every third, again the common bedroom sides, we can have bracing. So all my lateral load gets transferred to these bracing beams, and the rest of the connections can be simple fundamentally. So we have not tried to go into any high-end solutions or things, but similarly stick to very simple frames. And by using my bracing systems, we find that it's very easy to optimize my steel frame. Then we go on to just, some quantifications about what happens. We do a regular, we try to complete this analysis. There could be some further refinements, but we find here that the cost per square feet with the decking, this is without anything else. What other things that we are trying to do here is that the walling for the toilets could be different and the walling for our main building could be different, because people normally prefer all the walls to, have provisions for your outlets, and if it's a wall, then they can have inserts, pipes running through, etc., etc. And those toilets being outside can be featured. So generally, this is about, nowadays, the rates of steel are less, so you'll find the comparison is a little more comparable, you can say. Normally, this could go to 750 also. And we have also done, instead of a decking sheet, with precast slabs. Precast slabs we have considered again 6 meters hollow core slabs precast. But there are some issues with the waterproofing of the part, which also takes up quite a bit of time. So here we find that again we are with precast slabs, about 70-75 rupees per square feet is being added to the cost. And the concrete frame structure, we find, as it is, concrete being the most efficient, or you can say economical material, it is still a little less. It's about generally 600 square feet. So that difference of around 10% still remains. But we could say we narrowed it down. And we look at the advantages of doing in steel and concrete. We were given this brief by a builder who's constructing about 10 towers every year. And he said he's worried about generating concrete. He has 2 batching plants on his site, and the problems with concrete are so adverse that he really would like not to touch concrete, not to try and do anything with concrete. So, I mean, we are discussing this, and we ultimately found out that yes, some advantages and disadvantages. It's lightness. I mean, it's very easily done. Those frames that we are doing, in fact, we are also trying to experiment with our main frames. Like, if we can provide some moment connections and fabricate a whole frame, it's only a 6-meter frame. The whole frame can be constructed on site, picked up and placed on site. So if we can do that, that also saves a lot of time. Our main problems are connections on site. But since here we can literally idealize the whole building into different sort of frames, this makes it much easier. Ease of fabrication, again, as I said, mass production basically because we only have 3 types of members in the whole building. We have, as we said, about 18 units per floor into 7 floors, and again, if that whole building is mirrored, again double of that. But in spite of that, we have only 3 types of members here. Again, fast, easy installation, erections. The biggest issue is non-shrinking, non-creeping at ambient temperatures. That helps a lot because normally builders today are trying to build buildings which are zero maintenance. So all these works are helping. Formwork, again, which is a very labor-intensive course, is not needed. Termite proofing, rat proofing, etc. And the biggest problem nowadays is weather. Normally here we lose out 2 to 3 months to weather, and now with the unseasonal rains and etc., that could go anywhere. So that also is reduced a bit. Again, the disadvantage, as I say, fire resistance, corrosion, and again, you have to handle it correctly. Since it's a small building, it's a residential building, our floor heights, etc., are not more than 3 meters. So buckling, etc., issues are not much. But yes, some deformation due to small sizes of members would positively creep into all that. Generally, to conclude, I would say when we have gone through all this, that from a builder's perspective, whatever brief we were given out to, the main advantage with all this was concrete is become such a big issue that, I mean, having to do so much of concrete, the quality control issues are quite a lot. Here we find that the quality control issue is practically eliminated because most of the work is fabricated and the connections can very easily be checked on site. Normally we find that on site there are various levels and various stages of checking, which is reduced a lot. The biggest advantage is that dimensional tolerances are controlled. I mean, we build a tower and we find that my first floor is 1 inch out, the second floor is in, and so many things. But here, the dimensional tolerances are quite controlled. Also, the number of agencies which are working on site are drastically reduced. I have 1 fabricator and 1 erector, that's all. Somebody is working on the shop and the others are just transporting it to the site and erecting it. So that also saves a lot of, you can say, supervision, manpower on site. Also, and due to the plan that we have fixed, there is a lot of flexibility in our design. I mean, if I want 3 rooms, I get 3 rooms. If I want 2 rooms, I get 2 rooms. And my toilet is attached anywhere. So that way also that builder is depending upon the segment that he has to build. It could be maybe 300 square feet, it could be 450 square feet, 500 square feet. It is easily manageable. So that is frankly what made it all feasible. And generally we find that though it's about 100 rupees more in cost, it has become a preferred option which we are actually experimenting right now. But I think in the next month, at least 1 building should be up and we should be able to actually correlate all the data. But generally, I feel yes, that it will work for mass housing at least. It should work. Thank you.